Local 5 is bringing the weather to a school near you with the Local 5 Weather Lab Experience. We're traveling to elementary schools all across central Iowa, performing fun experiments while explaining Iowa's weather. Visit weareiowa.com to sign up your school today.
I'm just so excited to introduce the Local 5 weather team to Van Allen today. Give them a hand.
We're thrilled to be here in Sheraton to bring you the Local 5 Weather Lab Experience. And this is truly an experience. We're going to do some awesome science experiments with you. We're also going to tell you how to stay safe when there's severe weather. And teachers, at the end, we have some fun for you too. And you can win a prize for your classroom. Okay, let's do some experiments. Who's excited? The pop versus soda.
All right.
I say it's pop.
Pop versus soda. So we got regular pop and diet pop. I need a volunteer from the front row. You were quick to raise your hand. Come up here, young lady. All right, stand back here. So here we have Diet Coke, thanks to the teachers that brought this. ours exploded in the truck. All right, so this is Diet. Right there, you hold that. And this is regular Coke. So are they the same thing? No. They're not, are they? What happens if she puts the Diet Coke in there? What happens to the can? Is it going to sink or float? Who says sink? Who says float? Well, let's see. Drop it in there. Oh! It is floating. It's floating. Well, that's interesting. So that one floats. What's this one going to do?
You think so? Whoa.
What is going on? Aren't they this? They're not the same, are they?
They look the same.
So what is the difference? What does this one have? It doesn't have, what does this have? What? It has molecules, everything does. Yeah.
I heard it.
Sugar? Sugar. This one has no sugar. Do you think sugar is heavier? It must be heavier. What was your name, young lady? Lorelei? Lorelei? That's a great song by Styx, by the way. But Lorelei, thank you very much for doing that. Give Lorelei a round of applause. Here, this is for you. That's a balloon. Go sit down. Thank you. So we learned about molecules. This has denser molecules. You know when the molecules come together? Sugar has dense molecules and it sinks. This one floats, even though they're both cans of pop or diet pop.
All right, Hannah, what's next?
All right, so this next one is called liquid layers. So what we're going to do first is I'm going to put some colored water here into this jar. And then next, I'm going to add some oil. Now, is oil going to float or is it going to sink?
You guys are smart.
You're smart.
All right.
They know how to teach them here in Sheraton.
Yes, they do.
We're almost out of oil. Does any teacher have any oil? Just kidding.
All right. So you guys were right. It does float. But I wonder what happens if we were to mix it together. I think I need a volunteer.
Ah.
All right.
Pick a good one, Hannah.
You in the brown shirt right there.
There he is.
All right. So I need you to stir it together really good.
You look strong. Come on, let's stir it.
There you
go.
That's pretty good.
All right,
There you
that's
go.
all.
Let's
It's
see.
all mixed up. He mixed it up.
Give him a round of applause.
Here you go.
Wait a minute. Wait a minute.
wait.
Something's happening here. Get this out of there.
No matter how strong he is.
They want to separate.
It's still separated. It still floats
So
to the top.
the oil molecules went to the top.
Yeah, it's because it is less dense. Now, what about syrup? Is this going to sink or float? All right, let's find out.
It's that darn sugar, isn't it?
All right. What do you think's going to happen? Oh, wow. All right, Hannah, what happened? Can you pick that up and show the kids?
All right,
You
it
see
looks
the brown
like
at
it's
the bottom?
sunk to the bottom there. Let's get it around on this side. There we go.
Do you see that?
Does anybody
Sunk
want
down
to drink
the
it?
bottom.
Who thinks Hannah should drink it?
I don't think I can.
Okay, all right. We'll go ahead and move on. So we talked about molecules being the makeup of everything. So we're going to focus in on air and water molecules specifically. So water molecules don't always have to be visible in the form of liquid water. It can be a gas, and that gas is all around us. Even inside this building right now, there's water molecules floating all around us. And they're not very dense at all because they're floating around in the air, right? Well, clouds are made up of these water molecules, and they also tend to float up high in the sky. So they're not very dense. But to be able to see these clouds, we have to go through a process called condensation. And it all starts with a little speck of dust. Those are the little brown, orange dots there. Those are floating around in the sky too. But it tries to cling to these water molecules and gather them. And eventually it becomes large enough you can see them, and you see the cloud form. And eventually the clouds can't hold any more water, so where does it go? It falls to the ground in the form of rain, or maybe that's snow that we're going to see on Wednesday morning, right? Okay, so
Wait, what?
we want to have a pet cloud here. Very simple experiment. So I have rubbing alcohol here. We just dyed it blue. And we're going to add a little bit of that into this bottle. Doesn't need to be a lot, but this is going to serve as that speck of dust that's floating in the sky. Rubbing alcohol evaporates really quickly, so if I shake it around, it's getting it into the air on the inside. So now that we have that suspended, okay, there is an equation in science we call the ideal gas law. It says pressure equals temperature. So what we're going to do is we're going to pressurize the inside of this bottle. And so if we increase the pressure, what's going to happen to the temperature? It also goes up. So in the summer, we talk about it being muggy, right? That quite literally means there's a lot of moisture in the air. Warmer temperatures can hold more moisture. Colder temperatures, we don't call it muggy in the winter ever, do we? It's because there's no moisture. So if we increase the temperature, we're going to increase the moisture, or the pressure in, sorry. If we increase the pressure, we're going to increase the temperature, and we're capable of holding more water inside. But what we're going to do is we're going to pop the top of this, and it's going to release the pressure, so the temperature is going to go down, and it's going to cool. And cold air can't hold very much water, so it has to go somewhere. Give me a countdown from 5, 4, 3, 2, 1.
He made a cloud.
You see that cloud? Okay.
Watch it go away.
But remember I said if you increase the pressure, temperature goes up. Warmer temperatures can hold more water, so the cloud goes away. One more time.
Oh!
So, oftentimes, if you've ever watched us on TV, we talk about high pressure and low pressure. Typically on high pressure days, it's clear and sunny. And on low pressure days, it's rainy or stormy or snowy. Same concept. On low pressure days, we typically have a lot of clouds. Let's talk about our next science experiment. Let's make it rain now that we have the cloud.
All right, so we have the cloud, but not all clouds make rain. Or do small clouds make it rain, or big clouds?
No.
Big. All right, so let's make a big cloud. Give me a minute here to get it working. All right, so we'll get this big cloud in here, and these big clouds can hold a lot of water. They can hold up to swimming pool full areas of water. That is a lot of water. And at one point, it gets too much for the cloud to hold. So if the cloud just has a little bit of water, it's going to stay up in the cloud. It's not going to come down. But once it gets that point where it's too much water in it, can't hold it, it ends up going down to the ground in the form of rain.
So this is going to do the same thing we did before, but it's going to be even better.
Watch
All right?
this.
Give me a countdown in 5, 4, 3, 2, 1. Oh! There they go. They're everywhere. Catch them. Nope. No, you stay there. You stay there.
Yeah.
So that is electricity.
Pretty cool, huh?
How is that possible?
Did there. You know what? There's still another way we can show you the difference in air pressure. Okay? Who thinks we can crush this can using our minds? Use the force. Come on, everyone.
Jedi.
All right, one of you's not doing it, so we better do it using science. Hannah, you want to light the torch here for me?
Yes, I can.
Okay, what we need to do is we need to get a little bit of water inside this. It needs to be hot. Okay? All right, so I put some hot water in here, but we need it even hotter. We need it to boil. Okay?
Need a little bit more.
Okay, so we're going to heat this up to boil.
Yep.
And what's going to happen is steam is building up in here, and it's increasing the pressure on the inside of the can. Okay? So that is pushing against the inside of the can really, really hard. Eventually you're going to start to see the steam rising out of the top. So the pressure inside the can is really, really high. Now remember, if we decrease the temperature, what happens to the pressure? Do you know? Shout it out. It decreases the pressure. If you decrease the temperature, it decreases the pressure. So if we tip it over into this ice water, you're going to see this can implode. It's going to crush itself. Are you ready? You see the steam? Give me a countdown from 5. 5, 4, 3, 2, 1. Wow. And do you see how I'm touching it instantaneously and I was just boiling it? That's how quickly the temperature changed inside. So the pressure instantly dropped. It stopped pushing against the outside of the can, or the inside of the can, and it crushed. How crazy is that?
Wow.
Wow, I am just amazed. But wait, just like any good TV advertisement on TV. But wait, there's more. We have another way we can show you air pressure. This is called the exploding paint can, Hannah. Take it away.
All right, so who is ready to finally see something explode?
Yeah.
I thought so. All right. So what we're going to do is we are going to make this paint can explode, but for that to happen, we have to use a little science. So I'm going to take baking soda. I'm going to put that baking soda inside of this paint can. All right, that looks like it's good. I'm gonna shake it down just a little bit.
It is very wet over here. Be careful.
And now this cup, I gotta make sure it has something stable to sit in down there in all that baking soda, because I'm going to add vinegar in it. Now, when vinegar and baking soda end up colliding, they cause a reaction that helps build that pressure up and makes this paint can want to explode. So, let's get this vinegar in here. All right, I got my vinegar and I got my baking soda, but now I need to put the lid on and make sure it is tight, but I have to be careful and not cause it to tip over.
A little more on the left. There you go.
All right.
We prepped one right here just in case one of them doesn't work. So hopefully
this
we
out?
All right, I think I got it sealed really good. So, who's ready to see this happen? All right.
All right, 1 second here. Just in the front row, in case this lid comes flying. Just keep your hands up. You ready?
All right.
Give us a countdown.
Which one's gonna go first? Whoa! Wow.